before we go to projectile motion, let's solve an example in 2 dimensions. So we have the xy plane. This is the x and the y, and there it's on the ground, so it's not up and down, but it's horizontal on the ground. And we have a particle at t equal to 0. It's at r equals 3, 4, or you can say 3i plus 4j meters. So it's 3 units this way and 4 units this way, so it's located here. And also at t equal to 0 initially, so this will become the r initial, it has an initial velocity also in 2 dimensions, which is 2i plus 5j meters per second, which means, let's say 2 and 5, so it's going to be like in this direction. That will be the initial value of the y velocity, and it has an acceleration, which let's assume it's also in 2 dimensions, which is 1i minus 3j meters per second square. So the acceleration has a component to the right, which is the I, and minus 3j, so the acceleration is pointing in this direction. And the question is, where is it? What is r final and v final at t equals 3 seconds? Where will it be after 3 seconds, and what would be its speed, and what would be its direction? So we look at the equation, and let's first find the position x final, and we'll say it's x initial plus vi xt plus half axt square, and we have these numbers. X initial is 3, okay, that's this value. V initial is 2, that's this value. V initial in the x direction is 2. The time we want to be 3 seconds, which is this value, plus half. The acceleration is 1 and 3 square, and that gives us, let's write it here, that gives us a 3 plus 6 plus this, 13.5 meters. Now let's find y final. It's going to be y initial plus VIYT plus half AYT square. So y initial is 4, which is this one, and V initial is 5 times 3, half. The acceleration is minus 3 meters per second square, and the time is 3 square. And we solve this, and we get 5.5 meters. So the position R is 13.5 I plus 5.5 j meters, or we can write 13.5 comma 5.5 meters. So if this is 3, that's 6, 9, 12, 15, so it's going to be somewhere here, and the y value is 5.5, so that was 4 and 8, so it's going to be somewhere here. That will be the final position. Now let's find the velocity at that point. So we can write Vx final equals Vx initial plus Axt, and Vx final will be Vx initial, which is 2, and the acceleration is 1, so it's going to be 2 plus 1 times 3, so that's going to be 5 meters per second. And Vy final is going to be Vy initial plus Ayt. Vy initial is 5 and A is -3. So that's going to be -4 meters per second. And so the velocity is going to be 5I minus 4J. Or you can say 5 minus 4, comma, meters per second. But this is the better way of writing it. So this is 5 minus 4 means 5 this way and 4 this way, so it's going to be going in this direction. And so here it's going to be moving something like in this direction. So it started off from here in this direction, now it's going here in this direction, so apparently it must have turned like this. Now we look at projectile motion, which is slightly simpler than what we just did. A projectile is anything which on the surface of the earth is thrown at any angle. So if you take a stone and throw it at any angle, it's going to go up and it's going to fall down onto the ground. This path is the path of the projectile, and this object, the stone or ball or whatever you are throwing, that becomes the projectile. The difference between a projectile and a rocket is that the rocket has an engine, an aeroplane has an engine, so they are not projectiles. So if it just falls under gravity, could go at different angles and different heights, they are all projectiles. Now let's suppose that you have the ground here and we have a gun that can shoot at a specific velocity, and we keep the gun vertical so that the initial velocity is vertical, so the projectile will go straight up to some height and fall straight down. If the gun is at an angle, the projectile will go at this angle, and now it has an x component of velocity and a y component, so the x component will make it go along the horizontal, and so it's going to go like this. But the y component is small in this case, in case number 2, so the Vy for 2 is less than Vy for 1, because V1 was like that, V2 is the same length, so it has a smaller y component, and so it's going to go less high, so it's going to go to some height and then it's going to fall down. Now if we make the angle even smaller, the x component gets bigger. Okay, the x component of velocity gets bigger, but the y component gets even smaller, so it doesn't go so high, but it might go further because it stays it goes horizontally with a bigger speed, but it stays less time in the air, so maybe it won't go that far. So it's a combination of both. From the y equations we get the time of flight, how long it's going to stay in the air, and from the x equation we get the range. Okay, this would be the range, or the distance that it travels in the x direction. So if the y component is large, y component of velocity, it will stay a longer time, but it might have a smaller x component of velocity, so it might not go that far. Now as a combination of both, we can determine what would be the angle so that we have the maximum range, and we can also find the angle for maximum height, which is straightforward, it's 90 degrees, and well, for horizontal it's not going to be 0 degrees. Now if we look at the projectile again, goes like this. So here the velocity is in this direction, here the velocity is always in the forward direction, going to be like this, and here it's going to be like this. It's going purely horizontally here. Now it's going downwards. So in we have in the x equations we have an ax. In the y equations we have an ay, and ay is minus 9.8. So there is always an acceleration in this direction, and ax for a projectile is 0. Now the reason why it's 0 is because the acceleration is due to a force. If the force is 0, the acceleration is 0. Now gravity is pulling downwards everywhere, and so there is an acceleration that's downwards. But there is no force in this direction. There is no force. No force this way either. Well, if we ignore air resistance will create a small force which we are going to ignore. So there is no force in the x direction, which means the acceleration in the x direction is 0, which means that the velocity in the x direction remains constant. So if we break this up into its x component and y component, the x component, well, it doesn't look like that, but the x component in each of these will remain the same, and the y component will get smaller and smaller and become 0 here and become negative here. It gets bigger as we go down. So the x component, the figure is not made very well, but the x component will always remain the same. X component of velocity. Okay, that does not change because ax is 0. Now we can consider projectile motion in a different way. Let's suppose that the projectile is going like this. So we can say that if we take the velocity's y component and x component, then y final equals y initial, which in this case is 0, plus v initial yt, that's this component here, the y component of velocity, plus half a y t squared. Now we take that as 0, and vit, so if it after some time it reaches here, so vit would have taken it up to here, and this term is half minus 9.8 t squared, so it's minus 4.9 t squared. So that term is making the y lower. It reduces it. So this distance that it falls down is 4.9 t squared. So we can assume it's a way of thinking that the particle goes straight up to here, then it falls down, and from here it goes this way and then it falls down, it goes this way and then it falls down. So it's constantly, well, going up and falling down. And the same thing we can consider for a satellite in orbit, that if you have a satellite going in Earth's orbit, then at this point it would have gone this way, but it falls down. At this point it would have gone this way, but it falls down. So an object in circular motion is constantly falling down towards the Earth and stays there at the same time. Well, that's a way of thinking about it. To solve a problem in projectile motion, we would say ax is 0 and the rest of the things will remain the same, and that will change the x equations. X final is going to be x initial plus vixt plus half axt squared, so that's 0. V final x is going to be v initial x plus axt, which is 0, so we can remove that, and v final x squared equals v initial x squared plus 2a delta x. Again, this is ax, which we can also remove. So this can remove that also. So these become the x equations, and the y equations remain the same as before. Y final equals yi plus viyt plus half ayt squared, and ay is going to be minus 9.8. And we have the second equation, v final x equals v initial x plus a yt, and v final this is y, a final y, v final y square equals v initial y square plus 2a delta y. These are the y equations. Now we will use these to solve an example.